Hello everyone. Welcome back to Dr. Lou's VCE Physics channel. Today, let's learn together about the 2021 VCE Physics examination. We will focus on questions related to light as a particle. My explanations need to be revised. If any teachers, parents, or classmates find errors, please feel free to provide your guidance. Infrared is best suited to thermal imaging. Visible is best used for optical microscopy. Ultraviolet is best used for water sterilization. X-rays are best used for medical imaging. The diagram shows a circuit to study the photoelectric effect. A voltmeter measures stopping voltage, and an ammeter the current. To find the maximum kinetic energy, one must have the stopping voltage. This will be the reading on the voltmeter as the current reaches zero. Using the de Broglie equation, we calculate the wavelength of the motor. Please note the units. Here, the Planck constant is Js, not Fs. The mass is kg, speed is m per s, and wavelength is meter. We know the number of photons every second and are asked to get the power of a light source. Calculate the energy of a single photon, and then, time the number of photons to get the total energy per second, the power of a light. There are 3 wavelengths in each pattern, so n is 3. The work function is Planck constant timing frequency. We solve out the Planck constant, substitute the value, and then get the value of the Planck constant as joule seconds. The photoelectric effect supports the particle model. 1 photon per electron interaction. The first photon causes the release of the first photoelectron, and the wave model predicts an accumulation of energy over time. Combine the de Broglie and wave equation, solve the momentum, substitute the value, and get the final result. Since the photons strike the sail vertically and reflect elastically, the change of momentum is the double photons momentum. The striking time is 1 second. Using the impulse momentum equation, we calculate the force reflecting the photon on the sail. Substitute the value of the Planck constant, the value of speed and mass, then, calculate the wavelength. The mass of electrons gets from the databook. The scientists want an aperture for the electrons that forms diffraction patterns with the same spacing as the diffraction patterns formed by the X-ray photons. So, we first calculate the wavelength of the X-ray, and then the ratio of wavelength to diameter. The electrons will also have the same ratio of wavelength to diameter. So, we calculate the diameter of the aperture. We calculate the energy of the photon in eV because the energy level is eV. Then, identify the energy level on diagram 8.9 and 6.7 electron volts. From 9.8 to ground level, we can draw 10 lines. So, there are 10 transitions. In light as a particle, 5 multiple-choice questions are worth 5 marks, and 5 short-answer questions are worth 18 marks. The overall score for this section is 23 markers. With a total possible score of 130 points, the percentage for this section is 17.7% of the total score.
If you need my help, please add me on WeChat or WhatsApp, and send me an email. Thanks for your attention. Please note Dr. Lou's VCE Physics channel, Dr. Lou's VCE Chemistry channel, and Dr. Lou's VCE Biology channel.